Hi, I'm Ashwat Prasanna from the International School, Bangalore, India. My project represents a Collatz conjecture as an equivalent algorithm and then proves various novel patterns. But what is the Collatz conjecture? The rules are simple. If a number is even, divide by 2. If it's odd, multiply by 3 and add 1. In 1937, Lothar Collatz conjectured that if this function were applied repeatedly to any natural number, it would always eventually reach 1. Though verified computationally, this remains unproven to this day. It also has some encryption and blockchain applications. One of the most challenging aspects of the conjecture is this conditional step. So I first separated the component operations by expressing Collatz values as the product of two sequences. This allowed me to frame an equation for the conjecture. Then, using induction, I eventually showed that it is logically equivalent to a repeated algorithm. Motivated by the involvement of powers of 2, I switched to a binary lens, where some salient patterns began to emerge. Notably, the growth rate of the trailing substrings of zeros could help determine whether a number eventually reaches 1. To quantify this, I defined changes, a property giving the number of instances of adjacent unequal digits in a binary string, and helps count substrings with all digits the same. I noticed a threshold beyond which applying the Collatz function reduces changes. This threshold is called HK. I ran a computer simulation to show that this bound does indeed exist. Later, I developed a complete proof using the pigeonhole principle to derive a general expression for this bound. Ultimately, I used this to show that when changes in a k-digit binary number exceeds the threshold HK, applying the Collatz function reduces changes. This is a specific distribution. We can potentially use this to prove the convergence of the changes of values in Collatz orbits, taking us a step further to a conceivable proof of the conjecture while discovering new patterns in the function and its encryption applications. Thank you for listening.